Good afternoon, everybody. With this webinar, I welcome you to the second set of presentations introducing the new Pappenberger, the Director of Forecasts, and it's my great pleasure to present to you the new products and the latest verifications results of this new system called vorticity on behalf of the staff of the European Weather Centre as well as our Director General, Florian. With this presentation, I really try to convince you that it is a truly remarkable cycle showing significant gains in skill. For this achievement, I not only have to thank, of course, our staff and our many collaborators, but also and especially our member and cooperating states and their national hydrometeorological services for their continuous strong support. I do believe that this new forecast cycle demonstrates the strength of our common goal, embedded in European cooperation at its best. This is a new thing. We're trying to give you as much information as possible. This is for the first time, and as I said, this is the second set. We have split for this reason, we have split this presentation into two parts. We had a science part and we have an implementation operational aspect part. The science part was given earlier, a few weeks back, by Andy Brown, Director of Research, and you can still look at the recording or watch the slides if you want to by going onto the website. He showed you many examples why this cycle is so good and why this cycle contains really exciting science. He's highlighting new continuous data assimilation, which I will demonstrate to you, really brings massive or huge improvement in skill. We also updated the physics, for example, 1 hour radiation update frequency in the ensemble, which makes it in line with the high resolution. I'm not going to explain you any of that science. I'm not going to show you any of the science. I'm only going to show you results. However, if you want to look at them, as I said, go back to the presentation by Andy Brown. But this is, of course, not all. As usual, it is important that all the information which I present to you is published on the web. Actually, it's even more than I can actually present to you. But don't worry if you can't actually click on the link fast enough or copy the link fast enough. The presentation will be available to download later, or you can watch this recording later, or you look at the social media on our website to find this link. As I said, this page actually contains far more information than I will be able to present to you today in this short webinar. For some of you, in particular, the technical details may be of particular importance. For example, on this website, you will find changes to grip encoding listed, and what you have to do in order to really get the right forecasts, to really get the right fields, to avoid ambiguity in your retrieval, meaning that you would actually want or actually request that you're actually getting that. So I really urge you to go to this website, and even better, if you can, I either ask you to watch this website by clicking the I button on the page, which I've circled in red here, or join the mailing list to get the latest updates of any new forecast cycle. By this, if you do that, you're never going to miss anything, and I think it's going to be very helpful for you to really get the latest updates and technical details. Let's go on. Let's go to the real meat of this presentation. Let's go to what the new release candidate actually is. So as I said, it's cycle 4601. The release candidate phase has started yesterday at 12 UTC. From now on, there will be no changes that alter the model results anymore, and we've planned and confirmed implementation of the new cycle for the 11th of June, 12 UTC. You can find a full set of products through dissemination of test data and easy charts will be offered until the operational implementation of the new cycle. At this stage, the test data can be used to acquire longer time series, so you can do your own tests. And the test data are now available in dissemination, so they can be pushed to you. The test products are generated daily, shortly behind the real time from the high resolution, the ensemble ones, and are based on the operational dissemination requirements. By the end of the week or beginning of next week, you will find graphical display of this cycle in easy charts, and you're going to be able to look at the scorecards that we're going to present to you later this week. Actually tomorrow, not later this week. My presentation really is split into two bits. It's split into presenting the scores, so how good is the verification, and in the many and different products which are part of this new cycle. Let's start with the scores. In particular, I think I'm going to start with the ensemble scores because I think they are particularly exciting. This is what we call a scorecard. You're going to find this scorecard tomorrow on the web link above, the same web link as before. This is the scorecard for the cycle, for the ensemble. Each line is a different parameter. The two columns always represent a different geographic region. And you've got two different verification scores here, root mean squared error and continuous rank probability score. Blue means the scores are better compared to the current operational system, and red means the results are worse than compared to the operational system. These results are currently based on roughly 240 model runs for verification against analysis and roughly 290 model runs for verification. And we will update these results the more and more forecasts are becoming available. If you ask in terms of what seasons is, currently the current seasons which are in this verification scorecard is the summer 2017, winter 2018, and then the spring of 2019. And I have to say, I think it's truly exciting because if you look at this compared to our usual or to our other cycle implementation, this scorecard looks extremely good. We have only a very few deteriorations in the tropics, and it's mainly positive. Deteriorations in the tropics come from the anticyclonic areas, South Atlantic and South Pacific, and they are unfortunately due to a slight warming of the analysis and also due to the introduction of a 3D aerosol climatology. I was already warn you, these deteriorations are slightly more pronounced in the ensemble than the high resolution. I'm going to show you the high resolution scorecard a little bit later. And that has to do that the ensemble has slightly less spread. And the reduction spread comes to a change in the convection scheme, which creates a slightly more stable atmosphere. If we look on averages, the average improvement is actually 0.5 to 4%. For most parameters, levels, and forecast lead times. That's a significant jump. As I said, there are some deteriorations, and these deteriorations are 0.5 to 1%, and as I said, mainly the tropics, and as indicated, I already mentioned the reasons for that. So this is a very blue scorecard, it's a very good scorecard. Let's look at individual scores of this scorecard. For example, let's look at one of our particular often used headline scores, T850 temperature for the continuous rank probability score, and indicated in the blue area where it sits on this graph. What you see here is the continuous rank probability skill score for 850 hectocalorie temperature reaching 25%, so the day it reaches 25%. On the y-axis, you see the day it reaches 25%. On the x-axis, you see the years from 1998 till today. The red line is a 12-month running mean, and the blue line is a 3-month running mean. You can see the curve nicely goes up. And if you look at the right-hand side, you can see two different bars. You can see a bar. The bottom one shows the 4501, so the current operational cycle, and the top one shows our new cycle. And this is a tremendous improvement of 4 to 5 hours between the current operational cycle and the new operational cycle. From the upper air, let's go back closer to the surface. As you may know, ECMWF has been tasked in particular looking at extremes and looking at large errors. And for that, we have a new headline score, which is basically based on how often do we get 2-meter temperature wrong, or how often do we have errors in 2-meter temperature which are larger than 5 Kelvin. Here I've got a CRPS indicating we're larger than 5 Kelvin. Similar to before, I can show you a time series. In red line, you've got ECMWF, you've got other forecasting centers on this graph too, NSEB, the UK Met Office, and JMA. You have the fraction of CRPS values, which are larger than 5 degrees, and I'm going to show you the extra topics, and time step is 120 hours in advance. You can see this curve nicely bumbles down, and in the end, again, you see a difference between the current cycle, 4501, which is the top, and the new forecast, or the new cycle, the new cycle which will be implemented next month, 4601. And here we have an improvement of roughly 4%. Again, quite a significant improvement to what we had before. Which is of course particularly exciting because in the large errors, it's not just an average score, it's actually something where we can look at particular errors where we are interested in. So far so good. We moved from the upper atmosphere to the surface. By the way, the scorecard, as I said, will be available by tomorrow, end or lunchtime tomorrow. And you can look yourself, can look for yourself in the individual parameters, which may be of more interest to you than the ones I'm presenting here. Let's go to significant wave height. I think significant wave height is particularly interesting because we changed the new wave model. And here you have slightly different graphs to before. On the left-hand side, you have the old or the current model cycle called 45R1 in blue. And in red, you have the to be implemented cycle 46R1. And you've got a CRPS displayed, so the lower the better. And you show on the x-axis, you see the forecast lead times going from 24 hours to 360 hours. Impressively enough, in the waves, there's a verification against observations or against buoys. We actually have a gain of 6 to 8 hours in the medium range. On the right-hand side, you see the difference between these two graphs, the relative difference. And the normalized difference shows quite clearly that the error bars are above 0, indicating to you that this improvement is significant up to time step 264, roughly, or thereabouts. This is a huge improvement, and I don't think I've seen such an improvement in the wave parameters in the wave parameters for a while, and it's really due to a new wave model. I'm not going to explain to you exactly what this new wave model is. For that, I really urge you to go back to Andy Brown's presentation on science and delve into it and look into it, what has changed. That's what I want to say. Look to Andy Brown. So far, I've shown you ensemble scores. Ensemble scores are, of course, quite important because they do present one of the most important bits of our forecasting system. In addition, we have a high-resolution forecasting system. I'm going to show you just a few scores from that now. First, let's start off with the scorecard. As indicated in the ensemble, the scorecard for the high resolution is again extremely good. Blue is better, red is worse. Again, to remind you, each single line is a different parameter. Two columns always represent a certain geographic area on the globe, and you have two different types of scores displayed here, slightly different depending on the parameters. In addition, I think it's important to point out is that the gray area, if you look at the left-hand side, the gray area is verification against analysis, the dark gray area, or the light gray area against analysis, the dark gray area is against observations. And in the middle, you can see the wave forecasts, or the wave ones, which are here in the middle line. Anyway, it's based on 610 model results, so it is significant. And as you can see, it's truly impressively blue-colored. Improvements are in the order of 1.1 to 5% for the high resolution for most parameters, levels, and forecast lead times. I'm giving you a range here because obviously I'm looking at quite a lot of number of parameters. But more impressively, as you already have seen for the wave verification for the ensemble, we have large improvements in the wave forecast of 5 to 10%. Some deteriorations, similar to the ensemble, are in the tropics, 0.5 to 1%. And as pointed out, the deteriorations in the high resolution are less pronounced than the ensemble due to the reduced spread in the ensemble. Again, it is truly a blue scorecard. Let's go to a single headline score again. Let's choose this time Z500 anomaly correlation for the high resolution. Similar to before, I'm showing you a timeline, anomaly correlation at 500 hectopascal geopotential reaching 85%. So the day it reaches 85%, we're looking at the northern hemisphere extratropics. On the y-axis, therefore, you see the day. On the x-axis, you see from 2002 to 2019. In there, you have as a dark red line the current at the time current ECMWF forecasting systems. You have got other global forecasting systems in different colors displayed here too. As you may know, most of our comparisons are nowadays against ERA 5, so against our new reanalysis, which you see as a dotted line, so fixed forecasting systems. And if you look at the estimation for the future cycle implemented next month, you can see it's a bit more than 2 hours of lead time gain. The results are extremely robust because they are based on over 600 different runs. So So these are results which are already statistically significant, and having a 2-hour lead time range gain in anomaly correlation at geopotential, I think is fairly impressive. And if you compare it to previous years, you can see that this jump is actually quite pronounced. So far, so good. I've shown you how good this cycle is, and I've shown you how good the verification result of this cycle is. Let's move on to new parameters and outputs. You've requested over the years, in particular coming to the using ECMWF forecast forum, the UEF, a number of new parameters you wanted to have, and we started to introduce them, or some of them, in this new cycle. All these new parameters are expected to be added to the catalog for real-time products, pending the approval of the Advisory Committee on Data Policy. These new parameters can be obtained through ECMWF designation system, but only after the implementation of 46R1. However, don't despair, you can already look at these new parameters because we have actually archived them in the Mars archive, and you can actually retrieve them. Again, you will find more details about these parameters on the website, and I urge you to go to the website to find out exactly what's there. Let's start with one which was requested a lot, which is 200-meter wind. It's a 200 U and V component of the wind. It will be available in Grid Edition 1, and it's of course added to high-resolution ensemble. It was particular request from wind energy providers and individuals who work on the wind energy, and it's now there. Going from wind to the ocean, we've introduced a large number of new ocean parameters, and you can see here it's from wave-induced mean sea level correction to number of events in freak wave statistics to wave turbulent energy flux into the ocean. So a large number of ocean wave parameters. All these parameters are available in Grid 1. These parameters are available in the high-resolution wave model and the ensemble wave model, and they're also available in the high-resolution standalone wave model. So you can get from all these different designation streams. However, a small note of warning, ECMWF plans discontinue the high-resolution standalone wave model, and we will contact users of that very shortly in due course and invite them to switch to the high-resolution wave model, because the high-resolution wave model is actually coupled, the other one isn't. This is just a nice example displaying this. This is the height of the largest single wave in meters during an incident involving the cruise ship Viking Sky on the 23rd of March. What you see here is a forecast on the 23rd of March, looping through different lead times. And this was really only be possible to display and show due to recent developments in science behind nonlinear waves. Wave interactions will yield improved characteristics of the tail of the wave heights distribution. And you can see it's just off the coast of Norway, and you can very neatly see how this largest single wave in meters actually starts hitting the coast or moves towards the coast, which caused this cruise ship Viking to get into trouble. There's other parameters, other ocean parameters available at the surface. They're produced by the NEMO model. They range from sea ice thickness to mixed layer depth to depth of the 20 sea isotherm to the average potential temperature in the upper 300 meters. Again, all these parameters are available in Grid 1 edition. They're available in high resolution ensemble, and these fields are interpolated from the NEMO resolution to a regular 0.25 degree grid rather than the original resolution. Just to show you a neat example again, and now I've got the same problem as I had yesterday. This is actually, or was supposed to be, an animation of 300-meter ocean temperature for 4601 during tropical cyclone Fanny. And what you would see if this animation actually works, you would see the tropical cyclone Fanny moving over the sea towards India, and you would see the 300-meter ocean temperature underneath in colors nicely moving with this tropical cyclone. I think it's quite interesting animation. I think it quite neatly shows the interaction between the two. One of the parameters which we had a lot of requests was potential vorticity levels, 1.5 and 2. You can see the different short names and descriptions here. I don't think I have to mention too much about them. It's geopotential, pressure, and wind components on 1.5 and 2 PVU. Again, all these parameters are available in CRIP1, and they will be available in high-resolution ensemble. If you want to know more, again, please go to the website and have a look. ECMWF is the World Meteorological Center, is a World Meteorological Center, and as part of that, we've committed to produce certain parameters. In particular, we've committed to produce total precipitation of at least 25, 50, and 100 millimeter thresholds. We've committed to present to do 10-meter wind gusts for at least 10 meters per second, probabilities of 850 hectopascal, temperature with standard deviations, and what you can see in the bottom right corner is one of those plots which you soon will be able to see in easy charts or on the ECMWF websites. For example, in this case, probability of 24-hour total precipitation. It's important to note that all these parameters are available in CRIP2 rather than CRIP1, and these are available for the ensemble, as you may have gathered from the descriptions. I think it's important to note that existing event probabilities are encoded in CRIP1. However, as a user, this should not bother you much, because we are actually providing a software called ECCodes, and the ECCodes version, which fits to this particular cycle, is 2.12.5, and you find exact documentation for that on the website, which allow you really a smooth conversion between CRIP1 and CRIP2. So you just extract the data. If you use the software, you won't even notice what type of format it is, and it allows you to quite neatly to decode that these fields into whatever your preferred format is, or read them directly into your preferred programming language. In addition to the previous parameters, which are sort of a post-process parameters, we also have new extreme forecast indices, or and shift of tails. There are three different ones. There's an EFI and SOT for water vapor flux. I'm going to come back to that in a second. There's also now an EFI and SOT for weekly mean temperature for the extended range, so for each of the weeks 1 to 6. And a similar one for the total precipitation, again, each of them for weeks 1 to 6. Just to come back to the water vapor flux. The water vapor flux is the magnitude of the combined vertical integrals of the eastward and northwards water vapor flux component. The water vapor flux EFI complements the current precipitation EFI by really aiming to highlight the large-scale water vapor transfer in the atmosphere. In course, it complements precipitation one. It is available in exactly the same forecast steps as the precipitation EFI. So daily up to lead time 7, then 3 daily from there onwards up to lead time 10, and then 5 daily averages up to day 15. And I've plotted you one nice example here. The example shows a heavy precipitation event that hit California in February 2019. You may remember it. It was caused by a quite powerful atmospheric river, bringing air abundant in moisture from the Pacific towards North America. It's really nice because if you look at this graph, it's a 5-day forecast. You can see that actually atmospheric river can be or is predicted pretty well 5 days in advance. The total precipitation, which I'm not showing here, is actually also hinting to possible large accumulation of rains. And what the EFI for the water vapor flux allows you to do, and what scientific research has shown, is it actually gives you a little bit of earlier warning. You can use that to have an early warning of extreme precipitation in certain areas in the globe, and the relevant references are published on the website. There's one thing you need to watch out for. In this particular cycle, we've changed a lot of the climatology and a lot of the other elements from ERA interim to ERA 5. So the new IFS cycle in 46R1 will use ERA 5 to initialize reforecasts, and also uses the ERA 5 EDA to perturb the reforecast initial conditions. In addition, all the climatology which is used for the extreme forecast index and the shift of tail is now based on ERA 5. Previously, all this was based on ERA interim. And this actually addresses quite a lot of some of our issues which we saw before. For example, we had always very persistent high extreme forecast index values in some regions over East Africa. which were probably largely due to incompatible climatology. Era interim is a fairly old model cycle. It has been developed a very long time ago and wasn't entirely in tune and compatible with the current forecast cycle anymore. And because for the extreme forecast index you compare reforecasts started from era interim or era 5 with the current forecasting system, you can get odd occurrences. For example, if you look at the right hand side, and here I'm using always the new cycle, so 4601 is used in both of these plots, but the right hand side is initialized with era interim, and the left hand side is initialized with era 5. And you can see there's a very clear reddish signal in the right hand side in the two circles, which is the EFI, whereas this seems to be a bit less pronounced in the left hand side. We believe that the signal was incorrect or was erroneous, and actually with the new one, the new climatology, it's actually much better. And that's all due to new initialization. There's something important to point out to you. It's not exactly related to the cycle. However, if you're still using era interim, you have to be aware that era interim is now phased out. All of you and all of our users are strongly advised now to migrate to era 5, which is available for free from the Copernicus Climate Data Store. You can download this data already. They're going back to 1979, similar to era interim, and they soon even will have a real-time component. The last date which will be available in era interim will be the 31st of August 2019. Of course, it's published slightly later because it always takes a few months to be published. However, if you need reanalysis data for your products, I would recommend that you start testing and switching now before it's too late, because we will not be making available any more data beyond the 31st of August from era interim at all. So I recommend you to switch now. Just to wrap it up, 4601 key points. Implementation date, as I said, confirmed 11th of June, 12 UTC. There will be an earlier one probably available with 06 UTC, but we'll need to see about that. I've hopefully shown you there's a significant number of new products, a huge number of new products, and I hope they're useful for you. And we're really hoping for your feedback and really looking forward to know what you think about them and how they perform in your particular settings. The improvements are 0.5 to 4% for most parameters, levels, and forecast lead times. I'm deliberately quoting here the ensemble ones. Of course, there's other ones for high resolution. As mentioned again, watch out, there's some deteriorations of 0.5 to 1% mainly in the tropics. Again, I only presented you a very small set of the things there are. And if you want to have more information, please go to the Confluence website and have a look. If you have any specific or individual questions, please email us at servicedesk@ecmwf.int. Thank you very much for listening, and now we are open for questions. So Zainab is asking whether there will be a correction to sea salts again due to the change in wave model. I'll have to frankly admit I don't know the answer. I'll have to take this question back to our experts and ask. I'm really sorry for that. I can't remember. Brian is asking whether there's a question how the prediction of tropical cyclones in 4601 is. Indeed, I did not show you any tropical cyclones predictions, and the reason for that is because I'm just trying to go back to my notes. Is because there's actually not much change in the tropical cyclones. the performance of tropical cyclones, and I know in the previous one you asked for split into basins. There's no, I haven't got enough statistics for individual basins. However, in total, the performance is solidly neutral. There's nothing negative in the tropical cyclones, and there's a hint of improvements in the tracks, which are consistent with the improvements in tropical winds. But because they're really borderline significant, I'm not really would find it difficult to make a definite statement on that. So there's a neutral impact. Joe is asking why was the number 50 used for the EPS, 50 members. The ensemble number is always a balance between the amount of resources and an optimal number of trying to get details of a distribution in order to specify potential extremes. 50 was set about 1999, so a long time back. We always go back and re-evaluate the number 50. At the moment, the number 50 or 52, because if you count the high resolution and the control as well, still seems to serve us well. And I'm happy to send you the paper which justified the number 50 at that particular time. As I said, there's a continuous re-evaluation, and we always look where the number 50 is still right. Currently, we still seem to be fine with it. Javier is asking, what is the state of the art of point rainfall easy points? Have there been some improvements in this new cycle? The new point rainfall product has just been released on easy charts. One would hope, or one would expect, that with the improved predictability of all the parameters which go into, or all the different fields which go into the point rainfall, that the point rainfall product itself will also become better. However, one has to be a bit careful because, of course, the point rainfall product is a product which does concentrate largely on the extremes, and therefore one needs to have enough data to actually do a significant verification of that. And therefore, I cannot currently give you an exact result of the point rainfall statistics compared to the new, from the old or from the current to the new cycle. However, given that all the inputs have got better, I would be extremely surprised if not the point rainfall itself also would have improved. I hope this answers your question. Reforecast history. So let's just start from the CDS. There's no 4601 is not available to the Copernicus Climate Data Store. Copernicus Climate Data Store does not serve all of ECMWF's data. It serves mainly Copernicus data. In terms of reforecasts, we will produce reforecasts as we do in normal cycle. So you're going to have now a month at least of parallel runtime, and you've got roughly 1 to 2 months of 4601 data available in the Mars archive. Of course, as we started the parallel run, as I said, now we started also that you also have reforecasts. So you have the traditional reforecast now paired with the other ones, paired with the normal forecast available too. I don't know whether this answers your question on how much, but there's quite a few dates available. I'm aware that most users always want more, and again, this is a balance between resources and what we are able to produce, but hopefully you should be able to get most of what you need. Christian is asking, can you tell us how the model sees grid points that is over lake covered by snow? I'm not aware of any particular improvements in this particular point, because as you rightly pointed out, at some points the surface temperature was that of frozen water ignoring snow cover that completely isolates ice. I'm not aware of any particular improvement, but I will take your question back and ask again. Again, it's more one of the science questions. I don't think it has shown up in any of the scores, but I will post an answer to your question on the website. Jason, you're really pushing me. Any comments on performance improvements for tropical convective forcing modes and or relative fields in support of medium range to substance forecasting? I've got no plots, nor have I looked. I will have to. I'm really sorry. It's one of the other questions. It's too difficult for me to answer on the fly. I will have to come back to you with the answer for that one. Good question, though. Sorry for that. Jason says the deterioration of the tropics scares me a little. Don't forget, scorecards or overall model improvement always shows positive and negative parts. And if you go back to the last model cycle, we actually had quite a lot of improvements in the tropics. I hope 0.5 to 1% doesn't scare you too much. But scorecards are always something where some areas are better and some areas do show need for further improvement. And we do implement things consciously. So introducing the aerosol climatology or the slight warming of the analysis was not done easily in a way that we did want to deteriorate the scores. There are physical reasons for behind that, and we do believe that afterwards this will lead to an improvement. I think it would be interesting if you look at the scores and then maybe reevaluate or think whether your comment of it being scary still applies, and then I would be really interested to hear from you whether you see any impact on what you want to do or what you're doing with them. Are the 610 model runs quoted on the scorecard available as part of the reforecasts? Unfortunately not all of them. And the reason for that is that some of them are actually RD experiments, so research experiments. They're not what we would call an operational run. We put them together in order to get a larger sample for the evaluation. Unfortunately, it's slightly smaller than that. I think it's about a third which is available. Many users post-process high-risk to their temperatures using MOS and get great results. Why don't you do it yourself? Christian, very interesting question, but of course if many users already do it, there's a question why would we do it if others can do it so much better than us? I think it's great that they use I think what's far more exciting to me is that actually they use our 2-meter temperature as input and can from that derive value-added products and make our products even better. For that, of course, they do need already very good 2-meter temperature. They do need very good 2-meter temperature, wind, and whatever else is there. So I think it's quite exciting that others can use our data in a MOS or in other post-processing type framework. It is of course correct that Christian is saying that you would in effect remove bias with very little effort. That is of course correct that you could do that. But I do want to show you here particularly the raw model results, because many of you use the raw model results as an input to some post-processing or to some other type of product from which you derive from that. So I think the raw model, the performance and the quality of the raw model is still paramount in order for you to do better in your post-processing or your products. And there has been a study about 4 years back showing that if you actually compare the gap between post-processed and raw model results through time, the gap actually does not necessarily close. So even if the raw model results become much and much better, there seems to be always some space for post-processing too. But of course you can do remove bias, and we do show things like anomaly correlation, which are in effect a sort of way, crude way, of removing a bias in a verification framework. But post-processing is something I really recommend you to do, and if you want to get better, more locally relevant results or different types of input, that may be something which is suitable for you. Thank you, Christian. I think on that very positive note, we're going to conclude this webinar. As I said, if you want to ask further questions, just give us an email or comment on the website. Thank you very much. I'm just going to try to get up the website, the email again and the website. Thank you very much for listening, and thank you very much for joining in. And I hope you're going to enjoy this news cycle as much as I do. Thank you.